Okay, guys, welcome to lesson number 2 for cosecant graphs. In the first video, what we did is we used the amplitude, the period, the phase shift, the graph, a sine function. In this sine function that we had, it was a period of 4 pi, so it was stretched out. Amplitude was 1. But then we used that sine function to then draw our cosecant function because that's the inverse of sine. Okay, so I actually erased, it was in pink, I erased the sine function. We used the formula for finding the general asymptote for a cosecant, and that says any number multiplied by 2 pi, well in this case it's pi over b, but pi over b, pi over 1/2, will give us 2 pi, okay, for this function, plus the phase shift, and our phase shift is pi over 2 for this function. So we got the general asymptote, and we just plugged in 0, that gave us pi over 2. We plugged in 1, that gave us 5 pi over 2. Expression here. We plugged in 2, it gave us 9 pi over 2, just to prove to you guys the good asymptotes. So this is what the cosecant graph looks like. Now, I do want to point out one more thing that you're going to need to know. Okay? Actually, let me just pull out my notes real quick so I don't lose my train of thought. Okay, so a couple more things you're going to need to know. You're going to be asked for something. There are 2 endpoints here, and everything is consisting within the period here, the 1 period. We're going to ask for 2 endpoints here. Well, there's one endpoint, beginning and end. So one endpoint would be here, right here, pi over 2, because that's where essentially our period starts. And the endpoint, the second endpoint, which is where it's finishing off, right there at 9 pi over 2. Okay, so think of these as endpoints. Kind of like, I don't know if you guys ever done a box and whisker plot. You have endpoints, you have midpoints, you have quartile 1 and quartile 3. I don't know if you guys remember that from, maybe algebra 2 or algebra 1. Okay, those are endpoints right there, simple as that. Okay, what else do we need to know? We need to know. Well, obviously, if these are the endpoints, the midpoint will be that. Now, algebraically, this could be done too. You just add these two and divide by 2. Simple. Look, pi over 2 plus 9 pi over 2 gives you 10 pi over 2, which is 5 pi. But just like anything else, you want to find the middle of something, the average of it, you're going to divide it by 2. So 5 pi and then divided by 2 is going to give you 5 pi over 2. That's your midpoint. So algebraically, this can be done too. And then lastly, there's what's called the quarter points. Okay, so we're going to get the quarter points, and it's very simple here. If this is one of the endpoints and the midpoint, the quarter is going to be in the middle of that. So right there, it's actually going to be right there. It's the minimum of that. So it's going to be the relative minimum. So right there is going to be 3 pi over 2, and then that's going to be labeled as Q1. Okay, so we have an endpoint, endpoint at pi over 2, endpoint at 9 pi over 2. We have midpoint at 5 pi over 2, and we have Q1 at 3 pi over 2, so thusly Q3 would have to be at 7 pi over 2. We're just being in the middle of the midpoint and that last end. Okay, so everything is perfectly symmetrical. It's right in the middle there. So that's that. I am now going to flip this over. Okay. Disregard the unit circle for now. You can always get a copy of it online, or if you already have your cheat sheet in your unit circle. However, over here, the questions, graphs I want you to try. So you're going to do this on a separate sheet of paper, and the following videos you're going to see are you're going to get more homework problems. And so you're going to do this all on a piece of paper, and eventually you're going to take a picture of them and scan them and turn them in as homework to your teacher, whether it be me or Mr. Nakoji. Okay. Pause it and copy those down.